Problem 4-30. Consider the graphs of f of x equals 1/2 times the quantity of x minus 2 to the third power plus 1 and g of x equals 2x squared minus 6x minus 3 at right. So you see we have a graph here, a coordinate plane, and we've got f of x. This is our function f of x. It's cubic. You see our little step there. And then we also have g of x, which is quadratic, and you see that parabola shape right here. Located on our graph, we also see we have point A, we have point B, and we have point C here. So letter A asks us, write an equation that you could solve using points A and B. What are the solutions to your equation? Substitute them into the equation to show that they work. So we've got two functions, and you see that we have the intersection points are A and B. If this was a system of equations, points A and B would be our solutions. Now what they want us to do here is they want us to write an equation that we could solve using points A and B. So what we're going to do is we're going to take our function f of x, it equals 1/2 times the quantity of x minus 2 to the third power plus 1, and we're going to set it equal to our g of x, which equals 2x squared minus 6x minus 3. It might be easier to think about it like this. If we said y, if we change our f of x to a y, and we just think about it as y equals 1/2 times x minus 2 to the third power plus 1, and we also have y equals 2x squared minus 6x minus 3. Okay, if we think about it as just two functions in the form of x and y, where we have x as our input, y as our output, we want to know where they're going to be the same. If these were two linear functions in the past, you've learned, hey, let's take it and we'll use our substitution or our equal values method in order to solve it. We're going to do that right now to create our equation. So, since 2x squared minus 6x minus 3 equals y, and 1/2 times the quantity of x minus 2 to the third plus 1 also equals y, then we know that these two expressions have to equal each other, the same way that y equals y. So our equation ends up being 1/2 times the quantity of x minus 2 to the third plus 1 equals 2x squared minus 6x minus 3. When we take this and we turn it into an equation, it's no longer a system anymore. What we're really dealing with is just this equation. They wanted us to create the equation, okay, that we could use points A and B for solving. So we think about it now, these are the intersection points. However, when we look at our equation, we don't have a y value anymore. All we have is x. So when we were to go through and solve this, the solutions to this equation would be the x coordinates from our intersection points here. We can see clearly here that this point is the point 0, -3. So we're going to focus here on the x coordinate, which is 0. And over here we have 4, and our y value is 5, I do believe. And we're going to focus on that one there. Our solutions says, what are the solutions to the equation? Well, the solutions are going to be x equals 0 or x equals 4. Those are the x values that would make this true. Now let's take it here. They ask us to substitute our solutions in to make sure it works. So let's do that. So I'm going to take 0 first and plug it in. I'm going to have my 0. I'm just substituting it into my equation. Let me throw those in there in a different color so they just kind of stand out. And so we've got 1/2 times 0 minus 2 to the third power plus 1 equals, we've got 2 times 0 squared minus 6 times 0 minus 3. And if we simplify each side here, we should get that this is a true statement. 0 minus 2 is negative 2. Negative 2 to the third power would be negative 8. Negative 8 times 1/2 would be negative 4. And then negative 4 plus 1 should give us negative 3. If you need to take a second there and pause the video and simplify them out, that's fine. Go ahead and do that. On the right side, 0 squared is 0, times 2 is 0. We have 6 times 0 is 0, so we end up essentially with 0 minus 3, which also gives us negative 3. So that makes a true statement. Now, one thing to point out to you here, if you notice, what was our y coordinate over here? We said x is our solution to our equation, but when we plug it in to both sides of the equation and we simplify each of those expressions, we get what would be that y coordinate there. Each of those expressions equals that same output if it was in function form. So when we check x equals 4, when we plug in 4 in there, you can kind of expect to see that 5 will probably be the value of each side of our equation. Let's check it and see here. So let's do, I'm going to take it here and let's do 1/2 times, and switch the color up real quick so it stands out what we're plugging in. We have 4 minus 2 to the third plus 1. That should equal 2 times our 4 in this case. And that would be squared minus 6 times our 4. And we're subtracting 3 at the end. So make sure you plug in just one of the solutions into the entire equation. Don't plug in one on one side and one on the other. That wouldn't work. So we look to simplify this down. 4 minus 2 is 2. To the third power would be 8. Half of 8 would be 4. And 4 plus 1 would be 5. Here we've got 4 squared is 16 times 2 is 32. I want to write that down so I don't forget it. 6 times 4 is 24, so we're subtracting 24, and then subtracting 3. 34 minus 24 is 8, minus 3 is 5. So we know that that solution also works on that side. So our equation they asked us to come up with is right here. These are the solutions, and we've shown our work down here that it works out. Let's move on to part B. So part B says, are there any solutions to the equation in part A that do not appear on the graph? Explain. So what I did was I took it and I already graphed it on my calculator just for time's sake here. And you'll see here, this was our point A, this was our 0, -3. Right here, we ended up with our 0.45. And when you graph it there and you expand out far enough, you see here that it actually does intersect one more time. It intersects right up here. And this is actually the 0.633. So when the question asks, are there any solutions to the equation in part A that do not appear on the graph? The graph that they gave us does not show every solution. You see up here, this one only shows 1, 2 solutions. Our other solution would be up here a little bit higher. So we do have a third solution there. So are there any solutions that do not appear on the graph? You would want to say yes on this one. And then you could explain, yes, there is a third intersection point out there. I've also got the tables shown here. And if you look closely, we can say here that we've got this solution where our input here is 0, but then our outputs are the same. When x is 4, we also see that our outputs are the same. And when we have 6, we also have the outputs are the same there. So each of those is going to be a solution to the, or an intersection point there. The solution, though, remember, was 6, 4, and 0 for our equation. Now, letter C says, write an equation that you could solve using point C. What does the solution to your equation appear to be? Again, substitute your solution into the equation. How close was your estimate? Let's move up to our graph so we can see it again. So right now we're talking about point C here. And point C definitely lies on our function of f of x here. So we've got f of x equals our 1/2 times our x minus 2 to the third plus 1. They want us to write an equation that we could use point C to solve. So what we need to think about here is, well, I'm going to go ahead and change this so it looks a little bit more familiar to some of you. Y equals x minus 2 to the third plus 1. Okay, our point C here, what do we know about point C? Do we know what its coordinates are? The x-coordinate looks like it's somewhere between 0 and 1. So we could say, approximately maybe 3/4. We could say our x-coordinate's about 3/4 of the way there. We don't know if that's right, but we can just kind of say that's an estimate there. Okay, so we just know that that is an estimate. I'll point that out there. Let's say estimate. Well, we definitely know that the y-coordinate here is what? We haven't gone up or down at all, so our y-coordinate is definitely going to be 0 for sure. Now, in order for this to be a solution, it would have to make our statement true. Well, we know that 0 is definitely part of that point, so let's take that and plug that in over here. We could say that 0 should equal 1/2 times the quantity of x minus 2 to the third plus 1. This is the equation that they're looking for. We know the output of point C is 0, we're just not sure what the input is, but we can solve it here to figure out what it's going to be. I'm going to go ahead and solve that using the graphing calculator, show you a way that you can do that. So let's pull out our graphing calculator. All right, here, let me go up and let me turn this off. And you'll see I already have my function typed in here. I actually have both of them typed in. I'm going to clear this one out. And I'm going to graph it here. I'm going to do a zoom 6, so you go ahead and get that typed in, type it up, and it should look something like that. Now what we want to find here is we want to find when our y value is 0. Okay, so we're looking for what is x when y equals 0. Well, just like we did up above there, we've got this is like one function, okay? We can make this like our y1. Scroll a little bit there. And we could take this over here, and let's make this another function. Let's call this our y2. So when we put in our calculator here, I'm going to go down to y2, and I'm going to type in this half of my equation in as its own function. I'm going to put in 0 there. So we got one side of our equation, we got the other side. Let's take it and let's graph that now. That's going to show us where y equals 0. And if we want to find our intersection point, we could do a couple things here. We could say, let's get out our keystroke sequence so you can see here. Let's switch that. Let's clear that out. So remember, to find the intersection point, we're going to do second trace. We're going to choose number 5. We're going to need to mark one of our curves here, one of our graphs. So we're going to mark this one first, so press enter. And now we've got one on this one here. So notice if we move that left and right, it stays on there. So we're just going to go ahead and press enter. And hit enter one more time, and it tells us that our solution is for x equals 0.74007895. So what is x? What is x here when y is 0? X is approximately 0.74. Remember, our estimate there was 3/4, so we could say that our estimate was pretty close. It says, how close was your estimate? Our estimate was extremely close there, so we were pretty close to getting that there. So that is what our value of x would be. Now, if you have questions about this, make sure you ask your teacher. I'm going to move this out of the way here. Now, the last part of this question asks us, what are the domains and ranges of f of x and g of x? So let's go ahead and do that there. Let's do, for f of x, our domain, well, we'll see here, there are no breaks in our graph, and it looks like it's going to go on and on forever, left and right. So we could say the domain is going to equal all real numbers and our range for our f of x function here, remember this is the blue one, I'm going to just kind of, this is our blue one. Okay, our range, notice it's going up forever and it's going down forever there, and there's no breaks in between. So our range is also going to be all real numbers. Now some people write, you can write all real numbers that way. Some people like to use the inequalities. If you do it that way, you could say our negative infinity is less than x, which is less than positive infinity. You could say it negative infinity is less than y, which is less than positive infinity too. Those mean the same thing. Either one of those will work. Now let's talk about g of x real quick here, and then we'll be finished. Domain for g of x. Well, g of x is a parabola here, and notice it comes down here, and it goes up like this. But it's going outward to the left forever, and it's going outward to the right forever, and there's no breaks in it. So once again, we're going to have all real numbers. For our range, though, we may have something different. We won't have all real numbers for the last time. As we look at our parabola, it goes up forever, because both of these have arrows, and so it's going up forever. But when we go down here, we end up with a boundary point here. It stops down here. So what we're looking at there is we have one boundary point. So we're not going to have all real numbers here. We're going to have to figure out what is the lowest point of our graph there. So we know it's definitely less than our 6, our negative 6 down here. So we can get out our calculator again. I lost mine. Let me grab it real quick here. Get that calculator back out. Where'd it go? There. There it is. If we want to find our range there, I'm going to go ahead and I'm going to have to type in my function in here. So let's clear out what we just had in there. And let's do, we have y is going to equal 2x squared minus 6x minus 3. All right, let me clear this out. So after you have it typed in here and you want to find what your lowest point's going to be, let's look at our graph. So we see our parabola here going down like this. If you want to find the lowest point, here's what you can do. You can do second, go to trace. So we're going to the calculate menu. And our parabola, remember, is the bottom point. So we want to look at the minimum value of that parabola. So let's go ahead and choose number 3. Now it's going to ask us to mark boundaries so it knows where to look between. So we need to make a left boundary. So we're going to hit enter there. And then I'm going to arrow over to the right to create a right boundary. So I need to make a right boundary. So I hit enter. So now we've got these two boundaries and it's going to look between there to find our minimum point. I hit enter one more time. And it's going to tell us our minimum. Okay, the x value would be about 1.499997, so it would be about 1.5, but we're looking for the lowest point. So we're going to be looking for y is going to be at -7.5. That's what we're looking for here in our function. So let's take this, let's go back down here. We know that the point we have down here is at 1.5, -7.5. So that means that our lowest point is at -7.5. So our y values have to be greater than or equal to, let's do it like this, like set notation, y is greater than or equal to -7.5. That would be our range. I know there's a lot going on in this problem here, so if you need to, go back and rewind it, look at it again. If you have questions, make sure you ask your teacher. Hopefully this helped you out a little bit there. This is problem 4-30. Thanks for listening, and good luck.